Okay, um, welcome to today's lecture. Today's lecture is all about electronic configuration. I'm going to start by defining what electronic configuration is, and secondary, I'm going to talk about electronic shells. Lastly, I'm going to show you how electronic configuration is done. Okay, electronic configuration. So the alternative term for electronic configuration is electronic what? Structure. So that's the other name. By definition, electron configuration is the arrangement of electrons in shells of atoms. Or in other words, this simply shows how electrons are arranged in the shells of what? Atoms. Note that any atom at the center of the same atom or at the core of the same atom, there is a what? Nucleus. And that same nucleus, around the nucleus, there are rings, or in other words, there are shells. And in the same shells, that's where you can find electrons. And note that there are quite a number of shells around the nucleus of an atom. And these same shells, they have the maximum number of electrons they can what? Accommodate. So the maximum number of electrons each shell can accommodate is given by this formula. So 2n to the power 2. This is like a formula that we can use to find the number of electrons each shell can accommodate, where n is the number of what? Shells. For example, the first shell, which is near the nucleus, it can be represented by what? 1. And then the second shell around the nucleus can be represented by what? 2. And then you can substitute there to find the number of electrons it can what? Accommodate. Okay, now let's talk about electronic what? Shells. So the alternative term for electronic shells is what? Energy what? Level. So this is the other what? Word or the other term that we can use. Definition: a shell is a concentric ring around the nucleus. So around the nucleus there are rings like structures. So those rings are what we are calling what? Electronic what? Shells. And that's where the electrons are what? Placed. So the nucleus is also called the core of an atom. So the center of an atom is what? The nucleus. And around the nucleus, that's where the shells are found. And around the same shells, that's where the electrons are placed or found. The shells, in order of their increasing distance from the nucleus, are assigned by the letters K, L, M, and what? N. So there are quite a number of shells around the nucleus. So the first shell, which is just close to the nucleus, is represented by this letter K. The second shell by L, and then the third shell is represented by M, and then N is the last what? Shell, which is the fourth what? Shell. And these same shells, they have different numbers of electrons they can accommodate. For example, K can accommodate up to 2 electrons. This one up to L up to 8 what? Electrons. M 18. This one N 32. And I'm going to show how these things are what? Done. Okay, as I said about atoms, any atom that you know, at the center of the same atom there is what? A nucleus. And around the nucleus there are shells. And these shells are represented by these letters you are seeing here. For example, the first shell, which is near or closer to the nucleus, is represented by what? K. And then the second shell from the nucleus is represented by L. The third one represented by M. The fourth shell represented by what? N. And these shells you are seeing, they have different numbers of electrons they can what? Accommodate. For example, the first shell can accommodate up to 2 electrons. The second shell can accommodate up to 8 electrons. This third shell represented by M can accommodate up to 18, and the last shell represented by N can accommodate how many electrons? 32 electrons. And then I talked about the formula that can help us know where these numbers are coming from. For example, how did these people put 2 here where did these two come from, or how did they come up with these two. So there is a formula that can help us know the number of electrons these shells can what accommodate. So this formula is given by 2n to the power 2. I gave you this formula. So wait, I'm just trying to apply where these numbers are coming from. So have you seen K is the first shell from the nucleus. So K, I'll just say, since the first one to be represented by 1, therefore N it's same as 1. It's the first shell. So we're going to substitute here. So it will be 2, where this N substitute with 1 to the power 2. So what is 1 to the power 2, which means 1 times 1. 1 comes 2 times, so 1 times 1 same as 1. Now what is 2 times 1? Same as 2. So this is where this 2 is coming from, meaning the first shell can accommodate up to 2 electrons. Yeah, so that's what you're supposed to know about this one. And then let's do the second one here. So as you can see where L is, L, it's the second shell from the nucleus. So therefore it's the second shell. So therefore N it's equal to what? 2. Now let's use our formula, which is 2n to the power n. So 2, where is n? 2 to the power 2. So what is 2 to the power 2, which means 2 coming 2 times, so which is 2 times 2, which is 4. What is 2 times 4? That is 8. So the second shell can accommodate up to 8 electrons. So this is where 8 is coming from. So you can do the same with the third shell and the last shell to prove these numbers where they are coming. Okay, now let's talk about this other interesting part. Under this we are going to talk about ways of showing the electronic configuration. So there are two ways on how you can show electron configuration. The first one is by writing, and then the other one is by drawing. So by writing, how are you supposed to do it? So the symbol of an element is written first, followed by the number of electrons in each shell. So you need to write first the symbol of an element. For example, if it's sodium, you write Na is equal to, in the first shell, how many electrons must be there. In the second shell, how many electrons. In the third shell, how many electrons must be there. And then it must be separated by the dot. Example, show by writing the electron configuration in each of the following nuclides. So the first one is sodium. This 11 you are seeing, it's the atomic number, it must be down, while this 23, it's a mass number, it's the one on top. This C you are seeing the symbol, it's carbon. The mass number, the number on top, it must be 12. The down number, the proton number or the atomic number is 6. This is neon. This 20 is the mass number, 10 is the atomic number. Lithium, it's a metal. The mass number, the number on top is 7. The down number, the atomic number is 3. This is Crolene. The mass number is 35.5, and then 17 is the atomic number. So let's try to work out this. Okay, now let me try to show you how electronic configuration is done by writing. So on the first part, on A, we are having sodium. The symbol is Na, and then on top it's 23, that's the mass number, down 11. And then B, this is the way it's supposed to be, not the way you are seeing it there. There was an error, yeah. And then carbon, the symbol is C, it's having the mass number of 12, down 6. And then on C we are having neon, which is having 20 on top, 10 down. And then on D we are having lithium, which is a metal, 3, and the mass number of 7. The last one, it's what? Crolene, which is having 35.5, and the atomic number of 17. Okay, solution. So the first one, How is this electronic configuration done? By writing on the laws there. Firstly, you need to write the symbol for the element, like this is the symbol for the element, and in this case we have been given sodium. So, and then second thing, you need to show or write the number of electrons it's accommodating in the shells. And you know that sodium it has about 3 shells. Now in the first shell, how many electrons must be there? The maximum number of electrons. And in the second shell, how many electrons must be there? And the last shell, how many electrons must be there? So what to make you know the number of electrons it must accommodate in each shell, it's by octet law. It states that the first shell should accommodate up to 2 electrons. You remember that formula? Those things are illustrated. And the second shell should accommodate up to 8 electrons. The third shell can accommodate as many electrons, even up to 18. But under octet law, 8. So first shell can accommodate the maximum number of electrons. The first shell can accommodate is 2. Second, 8. Third, 8. So now let's come to this. And then when doing this electronic configuration by writing, you need to use the atomic number, the number down. So for example, the first shell should accommodate 2 electrons according to octet law, 2. Now these 2 you subtract from 11, you remain with 9. So second shell should accommodate up to 8 electrons. So here you're going to write 8. Now sodium is having 11, so remaining what? 1. So in the last shell, it can accommodate up to 8 electrons, but sodium here, so just 1 remaining here. So do you know what this means now? It means this one you are seeing, the last one here, this is the main reason why sodium is placed in group 1, because in its outermost shell there is only 1 electron. Yeah, there is only one what? Electron. So this is how it is what? Done. So all the elements placed in group 1, in the outermost shell there is what? 1 electron. So let's try to do this for carbon. Okay, now let's do for carbon. So the symbol, remember we are starting with the what? The symbol and then the number of shells now. So the symbol for carbon is C. Okay, that's a symbol. Now the atomic number for carbon is what? 6. So according to octet law now, the first shell should have how many electrons? 2. So from 6 you subtract 2, you're remaining with what? 4. But according to octet law, you must have what? 8 electrons. But looking at carbon, it's only having 6 electrons, so we're going to have 4 here. So this number 4, the last one here, meaning it has 4 electrons in the outermost what? Shell. And it has 2 shells. Carbon has 2 shells. So the first shell, there are 2 electrons there. In the second shell, there are 4 what? Electrons. And this 4 is showing that, or it's telling us that carbon is in group what? 4 of the periodic table. As I said for sodium, here the last number it's having 1, which means it has 1 electron in the outermost shell, and this simply tells us to say sodium is in group what? 1. Okay, now let's do the same for C, the electronic configuration for neon. So the symbol is E is equal to, and then looking at the atomic number for neon is what? 10. So the first shell according to octet law should have how many electrons? 2. So from 10 you subtract 2, we're going to have what? 8. So in the second shell, how many electrons should be there? 8, and it's 8 just like that. So this is the what? The final answer. This is the main reason why neon is placed in group 8, because it has 8 electrons in the outermost shell. So this is how you do it. So let's do for lithium. Lithium, which is D. Lithium, which is a metal. Oh, sorry, which is a metal. So here, what do you do now? Lithium is having 3 as the atomic number. So in the first shell, it's supposed to have 2. So now 2 you subtract from 3, you're going to have what? 1. And the second shell should have how many what? Electrons. Now lithium has 3, so here you're going to have 1 electron. So lithium is placed in group 1 together with sodium because they are having what? 1 electron in their outermost. So this is the main reason why these metals, sodium and lithium, are placed in the same group of the periodic table. Why? Because they have one outermost, they have 1 electron in the outermost what? Shell. Yeah, so that's how it's done. And then the last one for chlorine, let me write it here. So chlorine is a non-metal, the symbol is Cl is equal to, obviously this is 17, so first shell should have 2, so 2 from 17, that's 15, second shell 8, then the other, this is 10 now, the other shell should have how many? 8, but now this is same as 10, so 10 you subtract from 17, you're going to have what? 7, obviously. So this is the electronic configuration by writing for chlorine. So chlorine is placed in the in group what? 7 of the periodic table because of this last number you are seeing here, the number what? Okay, I said there are 2 ways on how you can show electron configuration. The first one we did, that was by writing, and I'm sure you know. The second one is by drawing. So how are you supposed to do it? So first thing, you need to show by writing, like the way we are doing it at first, and then you need to draw the shells in form of lines or circles just to show how these electrons are placed. And then the other thing, you need to indicate the number of electrons in each shell as what? Crosses or dots, but crosses are much better than the dots. Yeah. Examples: show by writing the electron configuration for each of the following nuclides. So there is this one for sodium, we have for carbon, neon, and what? Lithium. Okay, so let's do it now. Let's try to show how this thing is what? Done. Okay, so the first one is for sodium. So sodium, which is Na2311. So just by the step it's telling us, first thing you need to show by writing, like the way we are doing it. So remember the octet rule, first shell should have how many electrons? 2. So 2 from 11, you're going to have 9, and then the second shell should have how many electrons? 8. So we're going to remain with what? 1. So just by doing this, that's the first thing. And then the second thing, you need to draw the shells. Now you show how these electrons are placed, starting with the first shell, second shell, and the last shell. So I'm going to draw a circle like this, and then I'm going to write the symbol for sodium, Na, inside like that. And then first shell, this is the first shell, so it's having 2 electrons, so we're going to do the closest 2 closest like this, 2 electrons like that. And then third shell is having how many electrons? 8, so we're going to draw another shell here like that, and then it should have how many electrons? 8. So 2, 4, 6, 8. Have you seen? This is second shell. Now the last one, it's having what? 1, the last shell. So you need to draw another last shell like this, and then you need to indicate. You can place it anywhere, even here. Then that's how it's what's done. Then you have done by drawing. So this is very simple. And then let's do the other one for B. For B, we have in carbon there, carbon, which is C12, then 6. So let's start by writing. So first shell should have how many? 2 electrons. Remember octet rule, first shell should have how many? 2, second 8, third 8. So that's octet rule. So that's octet what? Rule. You need to take note of this, very much important. So first shell should have how many electrons? 2 electrons. Now 2 is subtract from 6, we're going to remain with what? 4. So even if you do this plus this, giving us 6. So we have done by writing. Now let's do by drawing. We need to show the shells now, the lines, the circles. So let me start by writing the first one, and then you need to write a symbol like this. Yes, and then First shell is having how many? 2. So this is the first shell. So like this. Yes, and then it's having 2 shells. So this second one should have how many? 4. Just by doing this, then you're done. As simple as that. So it's very simple. Let me do for neon. Neon. Or I'm sure for neon and lithium you can do it. It's very much simple. So okay, this is a table of elements. As you can see, there are about 20 elements here of the periodic table, and these are the most important elements on the periodic table that they like using in the Zambian syllabus. So you need to know the symbols for these same elements, the atomic number and the mass number for this same elements. Not only that, you can illustrate the electronic configuration by drawing and writing for fluorine, neon, magnesium, sulfur, for all these elements. Thank you for watching this video. Don't forget to like, subscribe and to share. Not only that, you can also comment so that I can know your view over this video if you enjoyed it. Thank you very much.